Welcome to my YouTube channel, Brainy Course. Please like and subscribe my channel. Your support is the foundation upon which we build captivating content. Thank you for subscribing and being part of our creative fortress.
My name is Alex, Global Manager for the MCN Administrators here in Costa Rica. My team is responsible for monitoring cybersecurity threats for IBM and clients and acting upon those threats to minimize any client's risk of data loss or exposure. As I look to hire new cybersecurity analysts and administrators, I look for technical skills, including operating system knowledge, such as Linux, macOS, Windows, database knowledge, cross-site scripting, malware, DDoS, and cybersecurity knowledge in general, especially around firewalls and antivirus. Soft skills as effective communications, as this is needed to engage the right people. Critical thinking, since every incident is different from day to day. Motivation, since analysts and administrators have to have the drive to pursue the solution to problems. In this class, you will hear from several subject matter experts from IBM globally who will start to build your skills on important cybersecurity processes, tools, resources, and terminology. Thank you.
As you just learned in Alex's welcome to this course, understanding the fundamentals of security is essential to the cybersecurity analyst's day-to-day duties. Hi, I'm Lou Fuca, a course developer for IBM's data security portfolio. I'll be with you through Course 2 to help tie together the material you need to master to be successful as a junior cybersecurity analyst. You'll be taught by IBM cybersecurity experts who will take you through modules on system fundamentals. Module 1 will show how people, processes, and technology can affect a company's overall cybersecurity posture. You'll learn how the service management framework impacts an enterprise's ability to respond to a cybersecurity threat. Are you ready? In this video, you will learn to define what is meant by the term IT security.
So what are we going to learn today? We're going to learn regarding IT security. What is this term that we hear? We have a term here in the slide, but I'm going to try to explain this a little bit better. We can define IT security as the practice of defending computers, servers, mobile devices, electronic systems, networks, and its data from malicious attacks. This term can also be known as information security or cybersecurity on the field.
In this video, you will learn to describe the purpose of frameworks, baselines, and best practices in an effective cybersecurity strategy.
And the last part of this session is frameworks and their purposes. We're going to talk about frameworks. We're going to talk about best practices, and here is just a good differentiation between best practices, baseline frameworks, normative, and compliance. So, in the organization, we will have a lot of things. We will have, for example, best practices. We will have a baseline, or we will have framework. A good example of framework is COVID, or a good example of best practices. In some cases, framework, it depends of your business, is ITIL. So those are good things, good controls that will improve, enhance your IT governance, your IT processes, your IT policies, your IT procedures. Those frameworks, those baselines, those best practices will improve the performance of your servers. For example, if you go and grab the best practices for Microsoft regarding the hardening of their database server, for example, you will have a best Microsoft SQL Server. You will have an improved Microsoft SQL Server. But that best practice, that framework is not something that you will have to have. It's a nice to have. You will have a lot of good practices. You will have a lot of controls. You will have a lot of good things. But if you don't have it, that's good. That's something that will not necessarily harm your business. If you don't have guidelines from Microsoft to implement the servers, if you don't have the guidelines from Cisco to implement the Cisco devices, if you don't have the best practices from COVID to improve your IT governance in your company, you won't lose your business. You won't be part of any kind of problem with your regulator, with your government. In the other corner, we have normative and compliance. The difference here is you need to implement normative, you need to have compliance if your business requires that. So, for example, there is something called HIPAA. HIPAA is a normative that will be part of any kind of healthcare company in the United States. So you could have in your healthcare company, you could have COVID, you could have a lot of ITIL processes, you could have all the best practices from your vendors implemented in your systems. But if you don't meet, if you don't comply with HIPAA, if you miss 2 points, if you miss 2 processes in HIPAA, probably you won't operate in the United States. You will have penalties from the US government because you are not complying with HIPAA. So that's the main difference between baselines, frameworks, and best practices, and normative and compliance. So as we mentioned, we have a lot of things. We have, for example, as best practices, as frameworks, methodologies that we could implement in our business to improve the way that our business deals with technology. And we could mention, actually, we already mentioned a couple of those. We could mention COVID, we could mention ITIL, ISOs. On cybersecurity, we have the ISO 27000 series. We have COSO. We have the PMI, the Project Management Institute, with a lot of project management methodologies. We have the developer recommendations. As soon as you start working with a network, or sorry, with a programming languages, you will have a lot of documentations. You will have a lot of information regarding the best practices that you could follow on your software in your systems to avoid any kind of security incidents, any kind of incident that will harm or will destroy your software.
In this video, you will learn to describe the various roles typical to a cybersecurity organization.
Roles in information security. Even though this is not the complete list of roles, because each organization may have specific roles for different information security areas. These are very common roles that you can find in large organizations, like the Chief Information Security Officer, which is a, we can say, fairly new role, introduced to make sure that there's a head and someone in charge of the information security division to supervise, manage, and be the leader of the information security tower. Now, then we have the information security architect, information security consultant specialist, information security analyst, security auditor, security software developer, the penetration tester, which is also known as a member of the red team, a vulnerability assessor. We also have the digital forensic analyst, who is part of a blue team, for instance. We also have the SEM, the engineer, the person who is familiar with different SEM technologies. So all these roles are very important, and if you notice,
they already existed in the IT realm, but however, we are now adding the security portion to these roles to make them more specific and make sure that they are security oriented. So they make sure that they guarantee that the organization follows security best practices and standards. To mention a few of the roles, we have the Chief Information Security Officer. As mentioned before, this is a high-level management position. This is the head of the security department and staff. Okay, so this person is responsible for supervising the entire security department, and it's a very important role that in the past was not very common, but it is now very common to see this specific position or this specific role in organizations. Now, the information security analyst is more of a day-to-day analyst. This person is in charge of analyzing events, alerts, alarms, and any information that could be useful to identify any threats. So this person should be able to verify, for instance, or analyze events that are collected by a SIEM, like I don't know, maybe Curator, ArcSight, Splunk, for instance. Be able to understand and investigate alerts from these specific SIEM platforms or any alarms related to, any health check of a specific device, anything that could actually lead to a potential threat. For instance, if an IPS is sending a threat alert to the SIEM, an information security analyst should be able to go to the SIEM, get the alert, investigate the events, and even go to the IPS to understand what exactly triggered it and be able to follow up on that to a resolution. The information security auditor, on the other hand, is in charge of testing the effectiveness of computer information systems to make sure that they follow best practices, they follow standards, specific regulations like the ISO 27001 or 002, for instance, that they follow at least the best practices defined in those regulations, and that organizations are as protected as possible.
In this video, you will learn to discuss how processes are important to our everyday lives and for IT security, and discuss the definition of a security operations center.
Hi, welcome to the training on business process management and IT security services. My name is Joe Spino, and I am a business process analyst at IBM Corporation. Today, I'd like to provide some insight and training after we go through a little bit of an introduction on business process management, or BPM, IT infrastructure library, commonly referred to as ITIL, and lastly, dig in a little deeper on some of the ITIL processes. And this all relates to IT security services. And let's get started. Processes are part of our everyday lives. We are engaging in processes personally and professionally. An example might be what I experienced yesterday. I had to get some money from my checking account, so I drove over to my local bank, the ATM machine. I inserted my debit card, which really kicks off the process. And internally, what I'm not seeing as the customer on the outside, internally within the bank system, it's going through a series of validation checks, looking at my card, trying to make sure there was no fraud involved, that my card wasn't reported stolen. So it's got a validation process. These are steps it takes internally. And then I plug in my PIN number, and it validates that. The system retrieves my account information. It'll go in and look at my account balance. Do I have enough money in there to draw some out? And it completes all of its checking. It asks me, how much do you want to take out? I enter the amount in the keypad. It will ask me how I'd like that and what type of bills. It updates my account and dispenses the cash. The cash comes out, my little card pops out, and the final step in the process, it spits out a little receipt that I take and drive off. So this clear process had a start and end, and I initiated it by putting my debit card in. Now, as IT security professionals, processes are very important in what we do. As you all know, the cyber attacks and alerts are increasing. The complexity of managing this environment is increasing. The attacks are ongoing and nonstop on our IT resources and assets. So we as IT security professionals are required to spend more time, focus, and attention on this, namely the security analysts. So it's important to have skills, processes, methods, and standards, because protecting our companies from outside cyber attacks is a critical job and very much needed today. The people, the processes, and the tools that we will use as IT professionals all need to work in harmony with each other for a given process. The security operations centers, and they may be called something different in your company or in your experience, but it's basically a pool of skills and resources that work to detect and investigate and stop threats. Within IBM, we call them security operations centers, SOCs for short. And in these SOCs, it's imperative we have the right skills, staffing. We have the right tool sets, for instance, automation, because if we can automate formerly manual tasks, that will increase the speed with which we can fix any issues that arise. So skills, tool sets, and processes. So people, tools, and process is kind of the industry way to look at the threefold model. And a key to success is the implementation of standard, repeatable, and measured process.
In this video, you will learn to define a process and its attributes, describe standard process roles, explain what makes a process successful, and describe process performance metrics.
I wanted to take us through just an overview on business process management, or commonly referred to as BPM. Now, there are varying definitions of a process depending on the author or the source, but, and I should say, some may call it BPM, business process management. In your company, it might be called QPM, quality process. There's Six Sigma, there's Agile, ITIL, CPI, different names, but underneath it should have the common elements that we're striving for. So a process is basically a set of defined, repeatable steps that take inputs, as you can see in the chart here, add some value, there's some processing, there's some knowledge applied, skills applied, resources within the process that produce a required output. And an output that meets customer requirements, whether that be internal or external clients, customers. Attributes of a process. Every process should have inputs, that is, some information, some data, or even raw materials that come into the process that are used by the process, and many times are a way to kick off the process. In my simple example, it was me putting my debit card in the ATM machine. That was the input. Every process should have a start and an end as well. Outputs are what the process produces, whether it be services, whether it be support, or an actual physical product, a widget. and it has to satisfy the original customer requirements. Each process should be bounded. It should have a front and a back. It begins here, it starts here, we do these tasks, and it ends here. It can't just go on infinitum. We've got to have a bound. So inputs, outputs, start, stop, tasks, steps, some call them actions performed. It's the doing part of a process that will lead to an output. Another key aspect I don't have listed on the chart, but documentation is critical in what we do. We have to have our processes documented for training purposes, just for common understanding of how it works, for auditing purposes, for compliance. And in my experience at IBM, I've always liked to use kind of a threefold approach to documentation. First is a high level, a one-page, very high level. Here's where it starts, here's where it ends, and here's a couple of boxes that shows what happens in the middle of the process. So just a one-pager. Then a mid-level, which is more what we call swim lanes, process flows. Left to right, it looks like an Olympic swimming pool. Each role in the process will have its own lane. And we list the tasks and the handoffs between the lanes. That's called a swim lane. And that describes the what versus the last level I like to describe as the how, or the DES procedure. This is how I complete task A, B, and C. This is what I sign into, and this is how I complete this. So high level, mid-level, the what, and low level, the how. Now this is certainly very high level, but each process, unless it's fully automated and all system generated, like my bank example, most of that was system behind the scenes. No people involved other than myself. But you could have a supplier that's providing something to the process team. You could have a requester that is requesting something of the process team that most of the time kicks off the process. And then within the process, you might have, and we see that a lot within IBM, we have a team leader, a very experienced person that oversees a group of folks that are executing the process and is there to lend support, to help when issues come up. That person is often an SME, a subject matter expert. It could be the same person, team lead, SME. And then you have some type of processor or person. It's really the person executing a step or steps in the process. And more often than not, you have some tasks or some actions need to be approved by management or another function before you can proceed in the process. So you need an approver and a reviewer. A reviewer might be a quality assurance person. The one critical item to know for any role in a process team, that there should be a separation of duties such that an approver is not the requester, because that would not be good sound business practice for me to request something and then, oh, by the way, I approved my own request. That would be less than desirable. So I would suggest a separation of those duties. So what makes a process successful? And there's certainly more than 6. But a charter is really describes, it's kind of like the menu. It describes what the process is in place to do. Why does it exist? What are the goals of the process? Who are the stakeholders in the process? It can be from 1 page to 30 pages. I've seen very long ones with charter. But it basically just, if anyone comes along and says, I don't understand what this process does, what it's for, here, read the charter. Processes should also have very clear objectives that, when met fully, that leads to you meeting your overall goals. Governance, ownership. I always suggest a process owner that is not a doer in the process. Rather, they have accountability for the success of the process. They are the focal point to upper management that says, let's go talk to Joe about how the process is performing. So they've got a name of the accountable person. It could be a manager or a non-manager, but just someone that is assigned the ownership of the success of that process. Repeatability, this is so important because that output, we want the outputs to be the same every time. We don't want them to vary. If we're producing brakes for a car, we want them to be the same every time they come off the assembly line. And variation is bad. So if our steps in the process are handled a little differently every time based on if person A does it this way and person B likes to do it a little bit different, just by preference, that could lead to variation, which could affect that output, and we don't want that. Automation is important too, because if we can reduce manual keystrokes, which are prone to finger error, it'll save time and money as well. And then lastly, but not all-inclusive, is performance indicators. Tangible metrics that we collect, we look at as a team monthly, quarterly, to say, hey, how's our process doing? I wanted to give just a very simplistic example of how it's important to reduce variability. If we look at just a fictitious company, R&R Manufacturing, that makes rivets that go into the assembling of the skins on commercial jet wings. We've all seen examples of where there has been breakage, catastrophic failure of some of the skins because of rivets, which is an awful thing. But in this example, this fictitious example, the RR&R quality assurance team reviews data on a defect rate, stress testing, rework, and costs on a monthly basis. So they collect metrics. They're interpreting. What are the metrics telling us? They're trending them out. They're looking at comparison of two different things. For example, process costs, the cost to produce these is going down month to month. However, if they look at that solely, it looks great. That's a good thing. Costs are going down. But if we take into consideration the quality and the defect rate, if the defect rate is going up, in other words, if I produce 1 million rivets and 2 are defective, that's 2 opportunities for failure of a skin on a commercial jet wing. So in this industry, I would imagine they have very strict tolerances that a widget has to be produced within very strict guidelines because we want 0 failures of a rivet at 30,000 feet in the air. So just a very simple example of how important it is to reduce variability, and that rivet is the same quality, high quality, every time it comes off the line. Process performance metrics. We need to measure our process so we can understand and improve our processes. Here are just some common examples. I'm sure there are many more, and many other types might fit under the umbrella of these. Cycle time is basically the timing of an event, a series of steps, or end-to-end process. My process starts here, the clock starts, 2 days later it ends, and I have an output. So my cycle time is 48 hours to produce this one item. And cycle time can be many different variations. It could be start to finish of a process. It can be a sub-process within a bigger process. We've measured delays before. I'm in the process. I go from step A to B, and I'm waiting to get to step C because I need information from another role. And I had to wait on average 24 hours. So we want to measure delays, bottlenecks, and those type of things. Put the clock on it. We also want to measure quality. Input quality, we get inputs from a source. It's good to check them. Someone provides pricing to us to start our process. We want to make sure those prices are right before we get too far down into our process. So it's good to measure inputs, the quality of those, the quality of our outputs, like in the rivet example, and in process, just meaning within the tasks that we're performing. Measure the quality. A lot of companies do sampling too. They'll sample every so many orders or processing items. They will sample them. Cost is just as it says. What are the costs of delays, of defects, of overtime for the staff having to work, those type of things. The last category is rework, which I just simply say are do-overs. I've gotten from step A to P, and I've all of a sudden realized something is off. I need to go all the way back to step D and start over. So I've got all that wasted time, my time, maybe system operation time. Maybe I need new materials. In manufacturing, I might have to scrap materials and start over. That's costly. So there's a cost to rework. And we want to measure it and then find out why there is rework, and then go upstream and eliminate that root cause. Continual process improvement, referred to a lot as CPI, is critical. It's just the ongoing cycle of always reviewing your process performance, metrics. What are your customers telling you feedback-wise? You could do maturity assessments, which are pre-developed checklists, questions that you can self-administer that will give you a score at the end to say, you know, on a 5-point scale, my process is a 3.5 in maturity. Maybe I want to get to a 4 in a year, and here's how I get there. And then financial performance. Small improvement teams are critical too, because I always think the smaller the better. If you've got the right key individuals and SMEs to get together from a department with the process owner and just review this stuff on a regular basis. Folks that are actually executing the process many times have great solutions and ideas. And in a small group forum, those ideas will come out.
In this video, you will learn to define the IT infrastructure library, describe service strategy, service design, and service operations as it relates to ITIL, and describe continual service improvement.
ITIL lifecycle, I wanted to take you just through a very high level of ITIL and their life cycles. This is not an IBM invention or development. This was developed outside in an industry, industry professionals, and it's been a number of years now, but it is a great method and framework. ITIL defined, it's really a best practice, like I said, framework, and I've seen it used across many different types of companies, public, private sector, IBM, we use it in many of our inner organizations. I think it has been very helpful. It is a framework provided to companies, not that it needs to be implemented exactly as the developers outlined it. It's a guideline. It describes really how we as an IT organization need to better organize and provide business value with all the IT processes that we implement. The developers of ITIL came up with lifecycle phases, which I thought was really great. And it's a very logical flow. Strategy, design, transition, operations, and improvement. So it's a very logical progression, if you will. For instance, service strategy. I'm in the IT organization of my company. I want to have a strategy that says, here's how I'm going to support my customers, which are a lot of the business units in my company, the finance group, the marketing group, advertising, the sales team. How am I as an IT group going to support them, and what am I going to provide? It's really taking understanding my offerings, my capabilities, and what I can provide to them as my customer. And within service strategy, ITIL has developed a number of sub-processes, like the ones listed here. There are actually more than I've listed, but this will give you a flavor of what they are suggesting. Service portfolio management is really how are we going to manage the service portfolio of what we provide. An example might be we provide help desk support for our internal organization. Well, is that 24/7? Are there certain parameters? But that is the type of thing we'll throw into our service portfolio. Financial management is really how we're going to budget, do our accounting, et cetera, to reach our strategy goals as an IT group, security group. Demand management is really understanding, anticipating requirements that might come to us by our customers, whether they're external customers or our internal business units. And then business relationship management is how are we going to maintain a positive relationship with our internal customers or external customers? What is the process that we'll use to ensure that we hear them, that we're taking action on what they say? So that was service strategy. That was the very first. And many of our organizations, as yours, we probably have IT processes in place, and we're not necessarily developing new strategies, but this is one way you can take a look at ITIL against your strategy, and there might be ways you can improve and refine your strategy. The next phase or cycle is service design. And this has to do with designing new services, IT security services that you might provide, as well as changes to existing ones. Some of the sub-processes include service catalog management. Ensuring there is a catalog is produced and maintained containing accurate information of all the services that we provide. The help desk example might be in that service catalog. Service level management, sometimes you might hear of this as SLA management, service level agreement. It's basically those written or understood terms between you and your customers on the levels of performance, setting targets. We're going to complete a help desk ticket within X hours, that type of thing, and then measuring performance against that objective. Information security management, this is just really ensuring the confidentiality, integrity, and availability of the organization's information. It's the data and the IT services. Supplier management, this is ensuring that we have contracts with those suppliers that we need to provide what we need as an IT security group to do our jobs. So that was design. Strategy, design, and then we go to transition. The objective of service transition is to build and deploy IT services, changing existing or new. And we're transitioning them from current state to a steady state. So things like change management, which we're all familiar with, the control of life cycle of all changes, that is under service transition. It's a process for ensuring we do changes with a quality aspect. It's project management, projects that coordinate the resources deploying, for example, like a release within your environment. Release and deployment, planning, scheduling, controlling the movement of releases to test in live environments. And within all these, communication is so important because this is not an area we want surprises where all of a sudden there are outages because we put a change in and no one in the business units knew about it. So communication cuts through all of these. Service validation and testing, ensuring that deployed releases and the resulting services, but they all meet customer expectations, whether internal or external. The last one I've listed, and there are other sub-processes under transition, but knowledge management is important. This is where we seek to gather, analyze, and store knowledge learned and information that can be shared across our organization, whether it's just in IT security in your company or across the corporate-wide. So then we move into the next phase, which is service operations. I call this one steady state because we've gone from transition, we are executing, we're in steady state, we're monitoring, we're executing, those type of things. And just a couple of the processes under service ops that I've listed here. Event management is a key. That's making sure that configuration items and services are constantly monitored. It's categorizing events and then taking appropriate actions. Incident management, this is managing the life cycle of all incidents. And we'll go into that a little deeper in a little bit. Problem management, likewise, managing the life cycle of all problems. And really the goal of service ops is to make sure that our IT services that we are providing to the business units or external clients, that they're delivered effectively and efficiently. And that's where that whole process discussion comes in, where reduce variation by having standardized, repeatable IT security processes. The last of the life cycle phases of ITIL, which is one of my favorites because this is what I've been involved in with IBM for many years, is continual service improvement, where it's just as it says. It's like we discussed before. We're continually reviewing metrics. We're identifying gaps in current service processes. We're looking for how we think it should be. We're trying to reduce the gaps. We're testing and prioritizing. We select what we think is the best opportunity to improve, and then we implement. So it's that continuous wheel. It's of always trying to improve your process.
In this video, you will learn to describe key ITIL processes, including problem, change, incident, event, service level, and information security management.
The last section, I wanted to just drill down a little bit more into some of the processes that I talked about at a high level. And there are so many resources available. You can Google and find wikis that really go into a deep depth on all the ITIL processes. There's a lot of organizations that do consulting on it. But really, there's a lot at your fingertips just by going in and Google searching on ITIL. So this is not by any means exhaustive, what I'm conveying here. This is just a high overview. So problem management, responsible for managing the life cycle of all problems. And that's how ITIL defines a problem, an unknown cause of one or more incidents. And problem management really aims to resolve not just the one problem that came up, but what's the root cause of incidents so we can minimize this happening again or the impact of further incidents. So it's really seeking to find and resolve the root cause of the problem. Whereas incident management is getting things back to a returned state of the service, to normal levels. Change management is just as it sounds. It's changes to baseline service, assets, or our processes, really, and configuration items across the ITIL lifecycle, those 5 phases. It's aiming to ensure that standardized methods and procedures are used for for effectively making changes. It can be changes to configuration items, process steps, tasks, systems, communication, again, is critical to reduce disruption of service and back out activities. Some of the phases within ITIL change management include identification of the change, planning the change, assessing the impact of the change, and then getting approvals, scheduling those type of things, and then implementing it. And post-implementation, we'll do a change review. What went wrong? What could have gone better? Could we have done something differently? Those type of things. And then a closure. And again, this is all documented in much, much more detail by ITIL that you can find online. Incident management, we talked about this briefly earlier, but this is aimed at restoring normal service ops as quickly as possible and minimizing adverse effect on business operations. And this directly correlates to service level agreements we have in place. So an incident is an unplanned interruption to an IT service or reduction, degradation of quality of an IT service. Some common phases it talks about in ITIL in incident management, in the lifecycle incident management lifecycle, would be to log it, assign it to someone that is going to resolve, track it, categorize it. There are different ways, different organizations as to how they categorize an incident. ITIL has its perspective: prioritize, resolve, and then close. Event management. An event may indicate that something is not functioning correctly. Events are any detectable or discernible occurrence that has significance for the management of an IT infrastructure or the delivery of an IT service. Within event management, we create and detect notifications. The monitoring function is key as well for checking. Service level management. This involves planning, coordinating, drafting, monitoring, and reporting on SLAs. We talked about that earlier, how we should have SLAs with our internal customers or external, and have an objective set, a bar that says, here's how we're going to perform. And as we measure, if we're not performing to that level, we know we need to make some adjustments. The last one that I wanted to just outline is information security management. This describes the structured fitting of information security in the management organization. So this is really the crux of what we as IT security professionals are involved with. It's having and maintaining ISPs and specific policies that address each aspect of strategy, objectives, and regulations. Some of the goals of IT security management are authenticity, accountability, non-repudiation, and reliability. I would urge you to look more into ITIL and business process management because it is a great framework for our IT security organization.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
In Module 2, Elio and John will cover what is known as the CIA Triad: confidentiality, integrity, and availability. You'll then hear from Priscilla Mariel Guzman Angelo from Costa Rica IBM Security Operations Center. She'll describe how she uses her skills during a typical day in the life of a security analyst. You'll also learn about the Information Security Forum, a not-for-profit organization that is dedicated to investigating, clarifying, and resolving key issues in information security and risk management. The ISF develops best practice methodologies, processes, and solutions that meet the business needs of its members. Let's get to it. In this video, you will learn to discuss the Open Web Application Security Project and find the top 10 web application vulnerabilities for each recent years and how to address each.
Another methodology, another best practice that most of the web applications needs to follow. Here's the OQASP top 10 process. So if you're dealing with a web page, if you're dealing with a web application, if you're dealing with actually not necessarily a web application, but if you're dealing with applications at all, you could use the OWASP top 10 and start performing tests on each of the sections that these organization will have on their website. So basically OWASP, and we will see here a lot of information on OWASP. If you go to Google and put OWASP on the search bar, you will go to the owasp.org link, and you will get a lot of information regarding this organization that will help you when you are trying to perform a test into your application, into your web application. Actually, there is also a lot of information for mobile applications too. So, for example, if you go to downloads, you will see a lot of categories here. So, for example, let's go to the top 10 as top 10 project here. Yeah, and you will see that the top 10 for 2017. It's now available. So here you will download the report with all the different information for the top 10 vulnerabilities for the web applications on the last 2-3 years since 2017. So for example, we have as a number one injection. So if we go to page number 7, here's an example of what is injection, what is the process to get information from the system using SQL injection, for example. What are the attack scenarios? What are the queries that you need to perform in the system in order to know if your system is prompt or is vulnerable to injection? And you have, for example, here broken authentication, sensitive data exposure. You have a lot of things to test, a lot of things to prove. And again, if you go to the main website, you will see a lot of downloads. There is something else known as the checklist. It's a document where you will get a lot of documents, a lot of controls that you will need to implement, you will need to have on your web applications in order to ensure that your system, your web app is fully secure.
In this video, you will learn to describe the Alice, Bob, and Trudy actors and what each represents.
Let's take a look at the playing field so that we can get the lexicon, the terms defined, and the actors. Well, so Alice, Bob, and Trudy, you see this throughout cryptography literature. And so it's A, B, and T are the actors, but back in the 60s, in a few papers, these were given names, Alice, Bob, and Trudy, and they continue today. So Bob and Alice, right, want to communicate securely. It can be for any reason, a personal reason or a business reason. Trudy, who is the interceptor, desires to intercept, delete, add messages, change messages, effectively a bad actor. So we take a look at the diagram here on slide 7, and we see Alice on the right-hand side, and Alice has some data. This could be an email, it could be a note, it could be a web page, a number of elements with that. And she secures this message, moving from clear text to ciphertext, transmits it across a channel. Now the channel can be any form of transmission that we can consider. So certainly email, direct transfer, file transfer protocol. It could be a text message these days. Back in the Napoleonic period, this would be a letter that a young naval midshipman may carry between Whitehall and other parts of London. So the channel, right, is the transmission mechanism, and within the channel is the data. This is the payload, right? Control messages. Who is it going to? How long is it good for? What's the address of the recipient, Bob in this case? Obviously in the internet world, we look at IP addresses, we look at MAC addresses. In the manual world, we think about the Napoleonic era when British intelligence started its ascendancy. This would be a name and a physical mailing address. So physical mailing addresses are manual interpretations of control messages. So Bob receives the message, decodes it, and has the clear text that Alice had sent to him. Trudy has the ability to intercept these messages on the channel, but because of the secure nature of the encryption, the protection for that, cannot read, delete, or alter those messages.
In this video, you will learn to describe the CIA Triad and how confidentiality, integrity, and availability are defined in the context of cybersecurity.
Three main components of a security architecture, and that's confidentiality, integrity, and availability. They protect data and services within the architecture. What you don't see here also is the authentication side and the access side. We'll talk more about that a little bit later. So let's take a dive a little bit deeper into the definitions for confidentiality, integrity, and availability. Is a NIST level definition of confidentiality. So let's take a look at this in some detail. So preserving authorized restrictions on information access and disclosure, including means for protecting personal privacy and proprietary information. So let's decompose this first bullet point just a little bit. So preserving authorized restrictions, meaning that we've got control protocols that explain not only how, but what mechanisms are undertaken to have access to the information at hand. And so there are authorized restrictions, right? This comes from the governance process, which implies that we will protect against unauthorized restrictions. What a great denial of service attack, for example, to simply prevent any access at all by authorized users. So we've got to preserve the governance, the protocol for access to the information. Obviously on information access and disclosure, so not only being able to read it, but being able to distribute that are under the purview of access control and maintaining confidentiality. For Bob and Alice, this absolutely makes sense. Right, so only Alice and Bob can change how they exchange information and how they protect that. And the means for protecting personal privacy, right, in the channel before Trudy intercepts, and proprietary information. Those are two main domains for confidentiality within the enterprise. And we define a failure, a confidentiality loss, as the unauthorized disclosure of information. Guarding against improper information modification or destruction. So this is the in-channel distribution that we're protecting information. Now, interestingly enough, there's some U.S. government agencies. They care more about integrity than they do confidentiality. So Alice to Bob, so Trudy can intercept that, but she can't, these government agencies have a laser focus that Trudy can't change the message. That's the integrity side. That's the guarding against the improper information modification. right? So a terrible, terrible set of circumstances would be that Trudy, in our earlier diagram, could modify a message and neither Alice nor Bob could be aware of that. So the simple "let's meet for lunch today" could be changed to "let's meet for lunch tomorrow." One person shows up, they feel like they're stood up, all sorts of complications occur there. So one can understand the impact to a mission of a lack of integrity. So also within the integrity side of this is the non-repudiation and authenticity components to this. Non-repudiation means that neither the sender nor the receiver, Alice nor Bob, can challenge that a transaction occurred. Well, let's define what the transaction could be. In a simple part of it, it could be that the lunch invitation was extended, the message was sent. So Alice can prove that the message was sent and can prove that Bob received the message. So Bob can never say, "I didn't get the message," because Alice would have the proof that it was sent and it was delivered. Now that's a simple non-repudiation definition. Let's take a look at a business transaction. In a banking environment, a transfer of $100 from a savings account to a checking account or from Alice's account to Bob's account. Let's take a look at the second. So the non-repudiation is Alice can prove that she moved the $100 from her account to Bob's account and that Bob's aware of that. So Bob could never say that $100 was never moved because we have message constructs, audit records that proved in fact that Alice made the transaction. Alice can prove that those transactions occurred also, so that it occurs from the sender side and the receiver side. That's the non-repudiation parameter that we're discussing in here. The authenticity element addresses the principle that it was a legitimate transaction. So the $100 that moved from Alice's account to Bob's account was conducted by their bank, not some third party, right? So this is that it is an authorized transaction. It occurred within the rules. There's no integrity violations. That's the authenticity side. So the definition of an integrity failure or the integrity loss is the unauthorized modification or destruction of information. In the larger context is that if Trudy, the interceptor, destroyed a message and prevented its delivery, that is also an integrity failure. So she not only changed the message, but she destroyed that. So our availability definition, this is the last of the three definitions on this, right? Talk about the timely and reliable access to information. Well, this makes sense. Basically, we talk about system reliability. The system will be available 99.99% of the time. That's the type of requirement that we see for system availability. The security engineer, the security professional, will take that availability requirement and be able to decompose that to the deployment architecture so that we can talk about availability for individual components, the sum of which will meet the requirement. So notice there are two components to this. So let's just take out the second one. We'll talk about the timely access to information. Right, so the ability that and this frequently is a system level requirement, that when a transaction request is put onto the channel, that the transaction response occurs within a set length of time, let's say 5 seconds. Now, for air traffic control radar and fire control systems, that timely access is measured in microseconds. So once again, frequently part of the system requirements matrix. The reliable access component. This is the actual system availability. So we're not talking about how long it takes, but in fact that it does take. And so we frequently talk about percentage of availability time on this. There's a couple of other parameters that can help define reliable access. But once again, the security professional will take a look at these requirements and perform a requirements decomposition and then allocate those requirements to elements within the architecture. So our definition of loss availability, right, is the disruption of access to an information system. That just makes sense, that it's going to have access responsibly, right, within a certain time limit, and in fact, that the transaction can occur.
In this video, you will learn to discuss what is meant by authenticity and accountability in the context of cybersecurity.
The last set of definitions that we will work on this module will address authenticity and accountability. Right, authenticity is the property of being genuine and verifiable. So when Alice sends Bob a message, that Bob can, in fact, prove that the message is, in fact, genuine from Alice and is the correct protocol and is what is expected and can be verified with that. And the accountability side of this is that Bob, receiving a message from Alice, can prove, in fact, that it did come from Alice. So we think about this in a banking environment, you instantly see the application that the banking system, when a action is taken upon the account to deposit some money, to transfer some money, absolutely maps that to a known individual.
In Module 3, Elio and John continue the cybersecurity discussion around access control and authorization. You'll explore the Open Web Application Security Project, also known as OWASP, whose mission it is to make software security visible. This visibility allows all individuals to see potential threats in their organization. The Access Control Reference Sheet is part of a larger reference sheet series that provides data and concise actionable guidance on access control and authorization threats. You'll be asked to perform a research exercise using the OWASP Foundation Top 10 project to hone your cybersecurity research skills. Let's get started. In this video, you will learn to discuss the terms identification and AAA in the context of cybersecurity. You'll also learn how to discuss the three types of authentication and the use of controls.
Identification and AAA. Identification. What is identification? It's when we first present ourselves against a resource. This could be by a username and password. This could be by a token. Let's use authenticating against a social network as an example. Once we present ourselves with the username and password, the application or the resource is going to authenticate us against its resources. So it's going to make sure that we actually exist under that environment. From there, it's going to authorize us, or it's going to give us the proper rights in order to access that information. If we're using the social network example, we should be getting a user type of role associated with us. We shouldn't be able to use any admin type of rights. From there, we're going to be able to have accountability to the things that we do. We spoke about this in an earlier chapter, so we're going to have the accountability of the things that we do with that ID or that authenticated ID. We're going to explain a little bit better how this works. In order to use a resource, we first need to identify to get the proper rights. and the authorization in order to use that resource. When we use that resource, we're going to actually get some accountability of our actions. So everything that we do is going to keep a log of things. Then we're going to talk about authentication methods. There are many methods out there. This can be summarized on 3. First thing is something that you know. What is something that I know? Could be a username and a password. Then something that I have. Usually this is being broadly used with banking trying to upscale their security. They usually give us a token or a smart card. Then that's something that you are. What are we? What can we provide? This usually falls with biometric controls. In this case, we're going to use fingerprints as an example. Something that you have. As you can see, this is something that we use on daily lives. We have a credit card with that chip. The chip is something that we have, and we actually authenticate with it. In some countries, for example, in the US, when you use a credit card, you need to put a PIN. That is something that I know. And then something that I have, I actually confirm that with the chip that I have. Also, the RCA token, when I authenticate against a banking site, I know that they gave me a user and a password. But the RCA token would actually create a random number or token in order to confirm that it's me that I'm logging to that resource. So something that you have is going to be something physical. It could be an app on your phone. It could be another piece of hardware, but it's something that you're going to actually have with you. Something that you are. What are we? What can we provide to a server or to an authenticating method? There are many things out there, things all the way from brainwaves, frequencies, but the most commonly used are fingerprints. Fingerprints, retina scanners, and biometric signatures, which could fall into anything really. What's the basic flow of this? It's going to start with the biometric capture. Then we're going to translate that image or that sample from the biometric capture into bits and bytes that actually the computer can understand and create an algorithm and find that pattern, unique pattern against us. It's going to take that and compare it against the one that it has on its database, and it's going to give us a match. Usually there is a range of error. In this case, for biometric capture for fingerprints, we have a 90% chance of actually being accurate for it. There's a 5% error. Controls. We're going to speak regarding controls that we have or that we use on our daily basis. This has been summarized on 3, administrative, technical, and physical. Administrative controls could be any policy or procedure that we have in our enterprise. It could be such a thing as a spam policy. For example, that many enterprises, if you receive an spam email, you must report it as spam. That is something that we can use to prevent that malware coming into our system. When administrative controls or when the user behavior is in place, we can also add a layer of security with technical controls. What could be a technical control? In this case, it could be a firewall. Not only we have a policy control that when a spam email comes into our work email, we need to report it. But in case somebody actually opens that information, we have a firewall. Also, we have our physical controls. Our physical controls could be anything that at this point, it could be a separate room with having different biometric controls in order to get in. It could be a wall, it could be a door, anything that actually physically restrain us from reaching that resource. So we spoke regarding the control types that we have, and we're going to speak a little bit of the subcategories that we also have on those. We have our corrective controls, which actually corrects the problem after discovering it. What can it be a corrective control? Could be a policy, trainings, any kind of penalty for breaking those procedures that we have in our enterprise. Preventive are things that actually help us to prevent or to uncover violations of internal controls. What could it be something that is preventive? Internal audits, random internal audits. Dissuasive, we are trying to, or with this term, we're trying to encourage violators. This could be a camera on a server room in order to prevent that type of odd behavior around the servers. Maybe a person would stop or would think twice regarding doing something outside the policy or the company's policy because his movements are being recorded. We also have our recovery controls with different things that will actually recover us in case of a disaster. On here, we could mention backups. Then we have our detective controls, which actually help us identify possible violations. On here, we can add our firewalls. Then compensatory. On here, if we were able to identify a gap and then it wasn't enough to cover it with a policy, which is an administrative control, we got a compensatory control, which could be a firewall, just in case that somebody actually clicks that spam email in order to prevent that from coming into the enterprise. We're going to add a compensatory control that will actually block any type of malware by adding that module into our firewall. On here, I'm going to share a little bit of a chart which actually goes a little bit more in depth into the control and type of controls. Also have the type of control, the preventive, detective, corrective, dissuasive, and recovery.
In this video, you will learn to discuss the major access control methods, including MAC, DAC, RBAC, and other methods such as centralized and decentralized. You will also learn to discuss access control best practices, such as the least privilege, separation of duties, and rotation of duties.
What do we mean by access control? Basically, it's keeping track of who has access to a resource or how we're going to handle this. There are multiple ways on how to do access control. We're going to go through the three main ones, which would be MAC, mandatory access control. This is usually used in the military when we have our classification of data. On here, a great example that we use is the traffic light protocol. You can check that out really quick. It's basically you're going to label each one of your documents, name it by TLP, amber, green, depending on the classification of the data you're actually trying to share. Also, that is widely commonly used. It's our top secret, secret, and classified. So MAC controls usually uses labels to regulate the access, most commonly used in the military. Then we have a discretionary access. Each object, file, document, resource has the owner and has the owner to define the rights and privileges. Basically, this is usually used on the small enterprise since it's a little bit hard to keep track of so many objects, files, and folders. The most widely used access control methods is our role-based access control. This is associated with you have a couple of users. Those users actually have a role, which are directly associated with the permissions that they'll get. For example, if you have a cashier doing operations, you'll have the role of cashier. Then if you have a manager, that shop, you're going to have the role of manager, which is going to have a little bit more permissions. This works to prevent a little bit of the giving the privileges or giving the access to resources to the person actually running our operations. What other methods do we have here? We have our single sign-on, which is a centralized type of solution, which provides us the three A's that we spoke earlier today. Then we have our decentralized solutions, such as the independent access controls. They're usually concealed into the local power and normally used by the military forces, such as in the battlefields. Under access controls, there's also a guide of best practices on how to handle your accesses. The three main ones are the least privilege, ensure that the people or the persons, the resource that actually needs to access that information only has access for that information that it needs to perform that job. Also have the separation of duties. Do not have many resources doing the whole lot of things. Let's say one of those employees or resources actually become disgruntled with the company. What it's the damage they could do if they had access to all the resources in there. We could minimize this by having the separation of duties and the least privileges. Also, a good practice that we have is the rotation of duties. Not only will help the employees to learn what the other departments are doing, but it will help us do the tracking and control of their duties. So for best practices, remember least privilege, separation of duties, and rotation of duties.
In this video, you will learn to discuss various common physical access control methods, discuss various common logical access control methods, and discuss monitoring and access controls processes such as IDS, IPS, host IDS and IPS, honeypots, and sniffers.
We're going to go to access control methods. This time we're going to focus on physicals. Physical access control methods go to perimeter, which could be a fence, to buildings, to work areas, and servers and networks. We usually, on the enterprise type of scenario for servers and networks, we have a guest network, we have an enterprise network. For work areas are the work areas that only authorized personnel can access to it. For buildings, also it's a kind of a physical access control, which should be having the separation of the people who can access that building. And then perimetral things as fences. A great example for this I like to give are the embassies in different countries. They usually keep it really well, or they actually do this really well. As per technical control or technical uses of the physical controls, what do we use? How do we accomplish it? We can use cameras in order to monitor who is going in and out of from an area. We can use traps or man traps. These are the doors that you actually need to pass a badge, and it will actually just let one person go through. We can use tokens. We can use lists and logs in order to keep track of who our persons are going in and out of that room specifically. Logic access control methods. We spoke a little bit of the physical. Now let's speak of the logic access controls. On here, it touch a little bit of the topic of ACL or routers. We can have a rule in order to keep each one of our resources we want to use. If we want to limit to the access on here, we can do it by an ACL rule. We have our GPOs or GOA policies or compliance solutions. We can enforce in their password policies, device policies, day and time restrictions. For example, if you shouldn't be seeing a resource connecting to a VPN network to access our enterprise server at 2 a.m. Eastern time. It's not our usual business, so that is something that we can actually limit. Also something that we can have that access control, it's for the accounts. We can have it centralized, decentralized, and actually enforce the expiration of those accounts. This all goes or circles back to the best practices that we got earlier on the course. So BYOD, BYC, BYU, everything, it's a popular concept being thrown out there. In order to enforce it with access control, it takes a lot of effort. We need that strict policy and understanding of the things that we're going to do. We need technical controls for MDM. We need training in order to have our resources properly trained to use those. Bring your own device, bring your computer, bring your own cell phone. So this also requires a strong perimeter controls for us. So it takes a lot of effort. Here's a little bit of a chart that was shared with us. We can see that 40% of our data breaches are associated with BYOD. At this point, the enterprises are pushing a little bit or pushing more into BYD, bring your devices, but they are not doing the same thing with their security policies. So on here, we can see a little bit of the charts that are currently shared. So monitoring the access control process. Now that we have reviewed threats and vulnerabilities that can cause damage to the organization, let's talk about the devices and techniques that can secure our hosts. The first thing that we're going to mention here is IDS, or intrusion detection systems. An IDS is a system that can scan, evaluate, and monitor the computer infrastructure for signs of an attack in progress. It requires hardware sensors and software in order to have the proper deployment on the environment. It's important to keep in mind that each implementation is unique and it depends on the organization's security needs. Also, always remember that an IDS, it only notifies you of the attack. Then we have our IPS, or intrusion prevention systems. An IPS has the monitoring capabilities of the IDS that we just mentioned, but it can actually block detected threats and still continue to use a passive response for other incidents. Then we have our host ITS and IPS. These are host-based systems that can monitor the host for unexpected behavior or drastic changes on their baseline. For example, it may include file integrity checks or to look for any outbound requests that could be a little bit suspicious. For example, using the threat intelligence IPs, looking for those outbound connections either on IPS or on IDS. If we wanted to kill that connection, we would use the IPS in that matter. Then we're going to mention the honeypots. Honeypots it's a security tool to lure attackers away from the actual network, where they can be monitored safely. While the attacker is on the honeypot, all the traffic and techniques are being logged to be reviewed. Honeypots can be software emulation programs, they can be hardware decoys, or entire dummy networks, which are also known as honeynets. Then lastly, we have our sniffers. Sniffers are also known as packet analyzers. It's a device or program that can monitor the network communications either on the wire or on the wireless network, and they capture that data. Those are commonly used while troubleshooting networks. Something before we finish on this slide that I want to leave really clear, it's the difference between an IPS and IDS. Please always keep in mind that an IPS, it's something that we can kill the connection or take action upon. As we can see on the image presented to the right, see item number 2, the one below, we see the attacker attempting to go to the target, but when the IPS detects that connection, it actually kills that connection. Instead of on the IDS, would it only let you know that the attacker is actually trying to go to that target. So that will be everything for the monitoring access control process.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
In modules 4, 5, and 6, Warren Perez, an SIEM administrator for IBM's Managed Security Services organization in Costa Rica, will give you an overview of the architecture, basic commands, and file systems for Linux. You'll also study the macOS and Windows operating systems to prepare you to navigate through system threats on the desktop. You'll investigate operating system commands and specific system resources using the Pentest Monkey reference site. Pentest Monkey is one of the many tools you can use as a cybersecurity professional. Shall we continue? In this video, you will learn to describe the Windows component's user mode and kernel mode and how they differ.
Hi there. I'm going to talk to you today about a few quick concepts for Microsoft Windows. Let's jump right in. Microsoft Windows, developed by Microsoft Corporation, has been around for a long time. Pretty much anyone who has used a personal computer within the last 20 years probably has some experience with Windows. But really the best part about Windows is it created the first graphical user interface that we're used to. So where you can go in and use a mouse to point and click instead of having to type in commands. And it was designed for IBM compatible PCs. So obviously Macintosh and Apple devices will run their own operating system. Windows will run on what we call IBM compatible PCs. IBM, as many of you may know, created the first personal computer in the early 80s. Approximately 90% of PCs worldwide run some version of Windows, and servers as well run versions of Windows as well. So it's something that many of us are very familiar with. So there are a couple components associated with Windows, or there are a couple components that Windows uses. They have a user mode and kernel mode components. User mode is really what you see when you are opening an application, when you're using Microsoft Word, or you're surfing the web with Chrome or Firefox or anything like that. You're really accessing user mode. And there are drivers that are used by that to create that I/O, that input/output that you're leveraging when you use an application like Microsoft Word, or, as I said, a web browser. And then there's the kernel mode, which is kind of the underlying technology within Windows, where you have different processes and threads that actually control the applications that you're leveraging within Windows and within the user mode of Windows. So let's talk a little bit about the user mode. So when you start a user mode application, Windows creates what it calls a process for an application. Anybody who's gone into Task Manager can see when you have applications that are running, you will see those processes running inside the Task Manager that will tell you things like how much memory it's using, how much CPU, and CPU is your processor, how much processor it's using as you use that application. The nice thing about applications is they're really pretty segmented from each other. So when you start an application, that virtual address that is created are private. So it's segmented from other applications within the environment. So one application can't alter data that belongs to another application. Each application runs in what we call isolation, and if that application crashes, it's not going to bring down the entire operating system. It's only going to bring down that application. So other things that are going on are not affected by that crash. If we talk about kernel mode, everything that runs in kernel mode contains a single or shares a single virtual address, so that kernel mode drivers are not isolated from other drivers and from the operating system itself. So if a kernel mode driver accidentally writes to the wrong virtual address or to something else within the operating system, that data within the operating system could be compromised. So if a kernel mode driver crashes, the entire operating system would crash. So you may have seen that where you get the blue screen of death, as it's commonly called, when your operating system stops and you have to reboot. That's typically caused by a kernel mode failure or a driver within the kernel mode writing to virtual address that would cause an issue with the operating system.
In this video, you will learn to describe the NTFS and FAT file systems used by Windows.
Okay, so let's talk about the different file systems that are prevalent within Windows. And a file system is what enables applications to store and receive files on storage devices. When we're talking about storage devices in Windows, we're mostly talking about a hard drive. So what's installed in your computer, it could be a spinning platter, which is a mechanical device, or it could be a SSD, a solid state drive, which is a non-mechanical device that stores that data. Files are placed in what we call a hierarchical structure. So you may have folders within folders within folders. And the file system will specify naming conventions for files and the format for specifying the path to a file in that hierarchical or tree structure. Just for definition's sake, a file is a unit of data in the file system that a user can access or manage. So a picture file is one file. It might be a JPEG or it might be a PNG file, but that's what we consider is a file. And every file has to have a unique name in its own directory. What you'll notice is if you copy a file within a directory and paste it in the same directory, it will put a number behind that file name just to show that it's the same file, just a different copy of it. And a directory, and you may be used to having it be called a folder within Windows, is a hierarchical collection of directories and files. And we'll talk a little bit more about that as we go on. So there are really a couple different types of file systems that are used within Windows. NTFS, or New Technology File System, is the one that is most prevalent today on operating systems like Windows 10, Server 2012, and 2016. That NTFS is what most of your drives will be formatted as. NTFS has been around since 1993, and as I said, it's really the most common file system for Windows. Both end user systems as well as servers that are running Windows will run the NTFS file system. There's also another kind of operating system that was really previous to NTFS, which is called File Allocation Table, or FAT. It's a more simple file system that's been really used since the 80s. And you may see different numbers associated with that FAT operating system, or excuse me, that FAT file system. And those numbers that precede the FAT or file allocation terminology refer to the number of bits used to enumerate a file system block, so FAT 16 or FAT 32. Mostly where you will see file allocation table file system is on removable drives. So if you have a USB drive or even a CD drive that's writable, it would typically be formatted as a FAT32 file system. And FAT32 can be used for devices that are less than 32 gigabytes in capacity. As we saw, hard drives get bigger than that. We needed a new type of file system, and that's where the NTFS came in. And now FAT is mostly used for smaller drives and smaller removable storage devices.
In this video, you will learn to describe the Windows directory structure and how Windows handles the separation of 32-bit and 64-bit applications.
So let's look at a typical Windows directory structure. And most of you who have seen Windows before have probably seen that everything is stored on normally the C drive. I don't know why it was called the C drive, but that's just what we call it. So your main hard drive is typically called your C drive. And these are the kind of standard file structure you will see on a Windows 10 device. So you'll have some folders that are hidden, and when they're hidden, that just means that they're not accessible to the end user unless you actually go in and unhide them within the control panel. So those are folders that Microsoft says, you really don't need access to those, so we're going to hide them from you. And the main one that's hidden is called perf logs. And it holds performance logs, but typically it doesn't really hold anything. It's usually empty, but it is a folder that is one of them that's in the common directory structure off your C drive. And then you have kind of the meat of what's on the C drive, which are your program files and your program files x86. So on newer operating systems that can address more memory, we went to a 64-bit operating system. Some of you may remember that when Windows first came out, it was a Windows 3.1 was actually a 16-bit operating system, and then Windows 95 became a 32-bit operating system, and we had various versions of Windows operating systems, both 32-bit and 64-bit operating systems. And the real difference between a 32-bit and a 64-bit operating system is the amount of memory that can be addressed. As applications came out that needed more memory to run, operating systems increased their bit to 64 in order to address additional memory. 32-bit operating systems can only address 4 gigabytes of memory, and for modern applications, that's just really not enough. So with Windows 2000, we started seeing operating systems that were 64-bit, and then XP and Windows 7, and then finally with Windows 10 are 64-bit. So, and the reason I go into that level of detail is because of those two different program files. So program files will store your 64-bit applications. If you have a 32-bit operating system, you won't have a program files x86 directory because all of your applications will be installed in the program files directory. On a 64-bit edition of Windows or a 64-bit operating system, your 32-bit applications will be installed in program files x86. And 32-bit applications can run on a 64-bit operating system. They are just separated, so you'll see where they're installed differently. And then you will also have a folder called program data, and those are files that are accessed by computer programs regardless of what user is logged into the system. So they're really files that the applications that you run need in order to work effectively independent of any user that might be logged on. And then you have your user directory. This is where your user profiles are stored, and each subfolder will be a different username. So as an example, all Windows operating systems will have a public folder So this is where end users might be able to share files. So if you have multiple people logging into a system, they can put something in public and everyone would have access to that file. And then you will have, in addition to public, under the users folder, you will have each username of people who have logged onto that system, or I should say who are authorized to log onto that system. So user files are typically stored in there. You may have lots of folders under the username directory. So you would have a documents, my documents folder, you'd have a pictures folder, a music folder. Anyone who's seen a modern Windows operating system will have noticed that. And then you will also have an app data folder. This would be like your program data folder, but for application data that is specific to an end user. So if you have a custom template within, say, Microsoft Word, it would be stored under your username and then the app data folder in order to separate it from other users who may log onto the system. And then in addition to that, you'll have your Windows system directory. And this is where Windows is actually installed here. And you'll have mainly 3 folders under that: your system 32, and your syswow 64. These are file or folders that really are the core features of Windows and the Windows API. So anytime a program asks Windows to load what we call a dynamic link library file, and it doesn't specify a path, these are the folders that are searched. So this is where Windows stores all the kind of system files that are needed to run Windows and provide the graphical user interface to the end user. Your system folder stores your 16-bit DLLs, and really will be empty on 64-bit editions of Windows, but the system folder is still there on 64-bit operating systems. Your system 32 will store either 32-bit or 64-bit DLL files, and what that really will depend on whether you're on a 64-bit or 32-bit system. And then your syswow 64 will only appear on 64-bit versions of Windows and store your 32-bit DLLs. And so that's really what you'll see when you open up a common C drive on a Windows system, either an end user system or a server system. These are the folder structure that you'll commonly see on a modern Windows operating system.
In this video, you will learn to describe what makes Linux unique as an operating system.
We're going to discuss some key concepts for Linux and the operating system. Let's start with the definition of what is Linux. Linux is an operating system. It's open source, and it's licensed under the General Public License, also called GPL. This license guarantees that the end users, basically ourselves, have the freedom to run, study, share, and modify the software. But this has one: you can study the software, you can modify it, you can share it, but as long as your modifications are also licensed under the General Public License as well, or the GPL license. Linux has some components, but there are 2 main components that we're going to discuss now. They are the kernel and also the shell. The kernel is basically the core of the operating system. It's designed to interact directly with the hardware itself. It manages the system and the user input-output, processes, files, memory, and devices. On top of that, we have the shell, which is like an interface designed for the user to interact directly with the kernel. On the screenshot in the middle of the slide, you will see what's also called like the CLI, or the command line interface. This is the shell for a Ubuntu system, and the user types in commands in this interface, then the kernel will perform those commands for the user.
In this video, you will learn to describe the various useful keyboard shortcuts provided by Windows.
So one of the nice things about Windows is we have that graphical user interface where we can use a mouse and a keyboard and other input devices to do things within the operating system. Certainly there's a command line interface that you would also see within Linux, and command line interfaces you're predominant way to access a Linux or a Unix system. But with Windows, the predominant thing that most people like about Windows is that we have that graphical user interface that makes it easy for us to interact with applications, with the operating system itself, and whatever you want. So one of the things that Windows does provide are shortcuts, and those shortcuts are things that we can do on the keyboard without having to move the mouse around, or just common tasks that we can speed up by using those keyboard shortcuts. And they're typically accessed by using the Windows and another key, or the Control key and another key. They're really time-saving and helpful for things that you will do regularly within Windows. So the first one we're going to talk about is Control and the Z key, or Control plus Z, to do an undo. And really, this is independent of the application, so it will roll back your last action. Whether you've overwritten a paragraph by accident in Microsoft Word, or deleted a file you didn't mean to, this is a great keyboard to undo your last thing, because we certainly all make mistakes, and I know I've used Control-Z probably more than I should, but it is really will help you if you made a mistake and want to undo your last action. Close is another one that you can use if you have a lot of windows open in your system. If you have the application or the window that is forefront in your system, if you hit Control plus W, that will close that window. And if you know, when you're in the middle of editing something, it'll bring up your prompt to save it. But that's another shortcut that can be handy as well. This is also very handy when you're copying and pasting text, especially maybe from a web page or from some source, and putting it into a document. But this will highlight everything on a particular page, and then you can take some action against it. And this is very handy, so you don't have to use your mouse and scroll all the way down on a long document or a long web page to grab everything on there. You just hit the Control plus A, and that will select everything on the document. Another one that is fairly prevalent and is helpful is Alt-Tab, which will switch your apps. So if you have, say, Chrome in the forefront of your screen and you want to move to something else, you can just hit your Alt-Tab. This will bring up a set of your windows, and you can switch to the window that you want without having to use your mouse to go to the taskbar and switch between applications. Alt plus F4 will close all your apps, and this is kind of an old school shortcut that's been around for a while, but it's very helpful. If you want to close all your apps, you can hit your Alt plus F4, and that will allow you to close everything and just exit to the Windows desktop. It will also, if you have something that needs to be saved within an application, will bring up the prompt to save it before it closes it, so you won't lose any work or anything. This one's also handy as well. If you hit the Windows button plus the D button, this will show or hide the desktop. So it's like a toggle switch. So if you have a file that you want to look at on the desktop, you can hit the Windows key plus D. That will show your desktop. You can look at the file name or do whatever you need to do, and then hit Windows D again, and this will go back to the application you were just in, so that you can go back and hide the desktop. So that's kind of a helpful shortcut for that in that regard. This will, the Win left arrow and the Win right arrow will move a window to one side of the screen, depending on which arrow you hit. So if you have a window that is not taking up your full screen and you want to move it to one side or another, so you can look at two windows at one time, using the Windows left or right arrow will snap it to one side or the other of the monitor and just give you more real estate to look at multiple windows at one time. Helps you keep things organized. And this Windows plus the tab will open the task view. This is something nice because it will show you a thumbnail of all the applications or all your open programs on the screen, and then you can go and switch between them. So it's just a faster way to open up the to switch windows, because you can go directly to whatever application you want to by hitting that Win plus the tab button. And this one will go back and forth through your options when you have a dialog box. So if you open up a dialog box within an application, tab or shift tab will move backward and forward through those options. When you have a dialog box that has a lot of choices, you can use tab or shift tab to quickly move through those without having to scroll your mouse. And this is just a faster way to do that.
In this video, you will learn to describe various useful Windows keyboard shortcuts.
F2 if you highlight a file and hit F2, that will actually give you the option to rename a file, so you don't have to right click and then hit rename. You can just highlight it, hit F2, and then that will bring up the box to rename a particular file. So if you want to do that in Excel or Word or any applications that you have, that will allow you to do that. F5 is refresh. This is kind of handy when you might be editing or looking at a web page and something changes and you want to refresh that web page. This will refresh it. So if you've made a change in your File Explorer or on a web browser, that will give you the latest version of the application or the latest version of the web page. So if something has changed, you'll see it immediately without having to move a mouse to click refresh. F5 is pretty handy for that. This is a great one as well, because you get up to go run to the restroom, you get up to go get a cup of coffee, whatever, but good security practices, you always want to lock your computer. Certainly you trust the people you work with, you trust your family members, but it's always a good security practice. I even do this at home when I'm by myself. It's just a habit now. When I get up from my computer, I hit the Windows L key, and that will automatically lock your computer, so that when you come back down, you can use your fingerprint, type in your password, use your face, whatever your methodology is for unlocking your computer. The Windows and L button will quickly lock it to keep it more secure, and it is a good security practice to do regardless of where you are. The Windows plus I key will open your settings. So this is mostly for Windows settings. So if you're in your desktop or actually in any application, you hit the Windows plus I, and that will bring up the settings dialog for Windows. And you can also use the Windows plus A to open up what's called the Action Center, which will show you your notifications and access to certain settings as well. So things like your network settings or your audio settings, those can be accessed as well. So Windows plus I will open your Windows settings, and then Windows plus A will open up your notification or the Action Center, so you can dismiss those notifications, or if you want to change your speaker volume or those kind of things, you could use Windows plus A for that. This is also pretty handy if you want to search for a file or a folder within Windows. If you hit the Windows plus S key, that will bring up a search dialog, and you can choose what you want to search, whether it's a particular drive or a folder. This will allow you to bring up the search dialog much more quickly than navigating to it through Windows. And this I use all the time. Printing a screenshot, if you hit the Windows plus the print screen button, there should be a print screen button on any keyboard you see, and that will allow you to basically save what's currently on your screen as a file, and it will copy that image to the clipboard. And if you don't want to do the whole screen, but you want to do a particular window, the active window will be snapshotted if you hit the Alt Windows key and the print screen button. So Windows key, the Alt button, and then the print screen button will only take a snapshot of the current active window. So if you want to show one thing but not your email that's in the background, you can use that option to just get the active window within the screen. This is really handy for diagnostic purposes. If you want to send somebody an email, you want to say, hey, here's the message I get. That window's active, you hit the Alt, Windows, and then the print screen, and then you get a screenshot of just that particular dialog box. You can then paste it into an email and send it off to somebody. This one is also very handy. If you hit the Control Shift plus Escape, that will open up the Task Manager. The Task Manager is where you will see what applications are running, what services are running on your Windows system, and how much memory and CPU they're taking up. And so this is handy just for diagnostic purposes as well. If you have an application that is hung, this is a way that you could go in and stop that application by just hitting the Control Shift and Escape key. That will bring up the Task Manager to allow you to do that. And then this is really on newer Windows operating systems. So Cortana is Microsoft's digital assistant, if you will, or virtual assistant. So if you want to open Cortana and ask it a question, hey, what's the weather going to be like today? You can hit your Windows C button, ask Cortana a question, and then she will be gracious enough to answer that question for you, either verbally or if she doesn't know it, go to the web and pull down information about that. So that's something that's nice that's been included with newer versions of the operating system. I think it started with Windows 8, but don't quote me on that. Okay, this is probably not as well used, but if you want to kind of clean up your screen and put open applications in there, you can hit the Windows Control and D key, which will open what we call a virtual desktop. And then you can switch from one desktop to another, and just so to clean up your windows and give you another space to work. If you don't want to have everything cluttered on one desktop, you can open up that virtual desktop and give you some more real estate, if you will. And then in Windows, there's actually a hidden menu that is separate from the Start menu. And this is accessed by hitting the Windows plus X button. And this is a quick shortcut to get into things like the control panel, or if you want to get into some Windows system kind of commands, or anything that is not part of the Start menu, but you want to get into a command prompt or those kind of things. These can be accessed by hitting the Windows plus X key, which opens that hidden menu within the Start menu for some of those applications that you still want to use but are just not included in the Start menu anymore.
In this video, you will learn what these useful Linux commands do.
Now we're going to discuss some basic commands on the Linux operating system. We have a list of basic commands, and we're going to go one by one. First of all, we have the cd, or the change directory command. This is basically a command used to change the directories of a user. These commands are all based on a text mode, like the CLI, for example, interface. So if you want to move from /home to /bin, you will use the command cd. The cp, it's the command used to copy files or directories. For directories, you will have to use special flags like the -r or recursive. Since directories have multiple files or directories inside of them, you have to use a cp command together with the flag that tells the copy command to do the copy recursively inside directories. The move command, it's similar to the copy or the cp command, but in this instance, the md or the move command will move directories from one place to another place. The ls command, it's used to list information related to files and directory, like owners and privileges, for example, and we'll see this in a little bit. The df command, it's used to display file system disk space. So if you want to know how the partitions are doing as regarding disk space, we could use the df command, and that will show us and print us information related to disk usage. The kill command, it's used to quote-unquote kill or stop an executing process. So if you have an executing process, for example, Apache running in the background, and you want to stop it, you could use the kill command specifically to kill that specific process or service. The rm command, it removes files or directories. You will need to specify the recursively or the recursive flag on that specific command if you want to delete directories. The rm can delete both files and directories, but we also have the rmdir, which basically will remove directories, but it has to be an empty directory to be able to be deleted. We also have the cat command. It's short for concatenate. You can combine several files into one, but it's also very useful if you want to see the content of a file. If you want to, for example, cat then text file, it would show you all the information inside that file in a command line interface. We also have the make directory command, or the mkdir. It creates a new directory, an empty directory gets created. So basically, you just type in mk dir and make dir and the name of the directory you want to create. The ifconfig, it's used to view or configure network interfaces. So whenever you need to check the network configuration of a Linux system, you can use the ifconfig command, and it will print you on the command line interface the information related to a specific network cards or all the network cards installed in the system. The locate command is very useful if you want to search for the location of files. This command uses an internal database that needs to be updated. And for updating the database, you will need to use the update db command. The tail command, it's also used to view the last 10 lines by default of a text file. You could also combine the tail command with the -n, and you could use tail -n and then specify the number of lines that you want to see on that specific file. You could also use the flag -f, and that will give you a real-time view or any file. This is very useful if you're reviewing log files, for example, that they change constantly. So you can use the tail -f, and that will pretty much give you a real-time view of that specific file. The less command, it's a command used to view huge log files. It does not load the full file while opening. It just basically loads the file as you move down the file. The more command, it's also used to display text, and this does it one screen at a time. So, for example, if you wanna scroll through a big file, it will do it one screen at a time. So if you scroll down on a file, it will scroll down the size of the command line interface at a time, basically. The nano command, it's a text editor. It's used to edit files. You could type in commands. You could delete information from the file. It's just basically like a Word program for the command line interface. We also have the ch mode or the change mode command. This is a very useful command used to change the privileges or the permissions on files and directories. We'll discuss this a little bit further.
In this video, you will learn to describe the basic Linux file and directory permission structure.
Now let's talk about permissions, both for files and directories. In Linux specifically, we have three quote-unquote groups that can own a file. They are the user, basically the owner of the file, the group, it's just like the group that owns the files as well, and everybody. That means the rest of the people that can use the file, or the rest of the users that are not the user or inside the specific group. If you turn your attention to the last image on this specific slide, you will see that W. Albert is the user of that specific file. Then you have support, which is the group that owns that file as well. And those two together, the user and the group, basically make up for the owners of that specific file. For each specific group, there are also three types of permissions that you can assign, with three basic permission types, right? For this specific course, we're going to discuss these three basic permissions. They're the read, the write, and the execute. These permissions have a octal value or a number, say 4, 2, and 1, but we also can assign binary numbers to these specific files. In this case, read has a value of 4 or 100 on binary, which is 4 in binary. Write has a value of 2, which is 010, which is basically 2 in binary. And execute has 1, which in binary is 001. Again, if you turn your attention to the last image on this slide, you will see on your left the file type, which is basically a file that it's indicated by a dash. And then we have permissions. We have 3 sets of permissions, and all of those have 3 specific permissions. The first set of 3 letters, it's for the user. We can tell from this image that the user has read, write, and execute permissions. On the second set of 3 letters, we can see that the group has only read permission and execute permissions. It does not have, it does not have a write permission. You can tell that by the dash. That means that that specific permission is not allowed in this group. And for the others or everybody else, we have no permissions at all. Here are some representations of what we just discussed. The octal value of the permission: 0 means no permission, 1 means that you can execute, 2 means that you can write. And you can also add those 2. For example, if you add the execute permission in the write, it will give you 3, meaning write and execute. You have 4, for example, it means that you can read the file. You could also use 4 and 1, which means that you can read it and write it. Read it and execute it, I'm sorry. 6 means that you can read it and write it. 7 means that you could pretty much do everything on that specific file, read, write, and execute. On the right side of the screen, you can see another representation of how those permissions are added. For the owner permission, we have a 7, meaning we have 4 for the read, 2 for the write, and 1 for the execute. This means that the bit for the read is 1, the write it's also 1, and the execute it's 1. So we have binary 3 ones, 1, 1, 1, that basically translates into a 7. For the group permission, we have 4, 2, and 1. That adds up to 5, meaning we have 4 for the read, 2 for the write, and 1 for the execute. And since we have, on top of the group permissions, you see that it has read, write, and execute, but the write has a dash. That means that we do not have that permission set up. So if you add 4 from the read and 1 from the execute, you will end up having 5. And that's where that number derives from. On the user permission, or the rest of the everybody, or also called others, we only have the read permission, and we have a dash on the right, and then the execute. That means we only have a permission of 4 for the rest of the users. These permissions are not set in stone. They can be changed, they can be modified, and that's where we use the ch mode or the change mode command. And this specific command, it's used as follows. Change mode, then we have the permissions that can be set as numbers. For example, 755, meaning 7 for the user, 5 for the group, and the other 5 will be for the rest, everybody, or the others, and then followed by the file name or directory. We could also be more specific on how those permissions are set. So you will use the change mode command. U stands for the user, equals, and then the permissions that we want to give to that specific user, meaning R and W, it's read and write. G stands for group. We're only giving read permissions for the group. And O stands for others, or everybody, or the rest of the users. And for this specific example, we are only giving read permissions to the rest of the users. Then that will be followed by the file name that we editing or the directory that we editing. In Linux, we can also change the owner, or the group owner, or the user that owns the specific file or directory. For this specific purpose, we'll use the chown command or the chown command. For this command, we'll type in chown, followed by the user, a colon, the group, and then the file name or the directory that we are modifying. On this specific case, if you draw your attention to the image below the command, you will see that W. Albert owns this file as well as support. If we want to modify that for the file name test, we'll use the chown command followed by, let's say, root, colon root, followed by the name of the file, in this case, test, and that command will change the owner and the group of the file name test to root and root. So the user root will own the file as well as the group name root will own the file.
Welcome to macOS Auditing, brought to you by IBM. In this video, we'll learn about where to find hardware and software specifications, as well as how to see all current activity, as well as where to locate any log files. Let's get started. The most basic place to start in gathering any information about a macOS operating system is to look within the About My Mac menu setting. It's the first option under the Apple menu, and on the overview screen, we'll provide a general overview of the hardware specifications, including the make and model, processor, memory, graphics, and the serial number of the device. There are 4 other tabs within About My Mac: Displays, Storage, Support, and Service. Displays is pretty self-explanatory, just lets you know what type of displays are plugged in. Storage will show you the internal storage capacity, as well as the distribution of how much media of any given type is on there. So it'll say there are 30 gigs of videos, 15 gigs of documents, and 100 gigs of photos. The support tab will link to useful links on apple.com for self-help, and the service will let you check warranty status and contact AppleCare if needed. Back on the Overview tab, there's a System Report button, which will launch the System Information application. This will actually host a much higher level detail of every piece of hardware, network interface, and software that is recognized by macOS, and of course is installed on this specific Mac. Useful information here can be found regarding what devices are connected or installed on the Mac. You could also see what software is installed under what versions, as well as any drivers that exist on the computer. There's also a section for diagnostic logs that specific applications will report to. System information is a great high-level overview of information, but if you want to get a current snapshot of what's happening, we'll need to look at Activity Monitor. Activity Monitor is the best way to get real-time information about everything that's actively happening. By default, Activity Monitor will open up to the CPU window or tab. What this will do is it'll show you every active process and application that's open. This is very similar to Task Manager within Windows. Also 4 other tabs: Memory, Energy, Disk, and Network, which, just like CPU, show each active process. For memory, it shows every process that's consuming the memory and what percentage of the memory it's consuming. Same with energy, disk space, and network activity. Activity Monitor is especially useful if you're looking to capture any volatile data that might not be there when you reboot. So if you need to capture exactly what's on the computer at this time, Activity Monitor is definitely one of the places to go. The last utility is Console. It's found in the Utilities folder and is macOS's application for logging any and all information. As you can see on the left-hand side, it conveniently categorizes the reports into different areas, such as application crashes or hangs with the spin reports, any log reporting, diagnostic reports, Mac analytic data, and the system log. What's nice here is that you can search for pretty much anything specifically if you're looking to pinpoint. If you're looking to monitor something, you can clear everything, or you can just hit the Now button, which will take you to the most current point in time where you can begin monitoring any specific log that you need. So between the system report, Activity Monitor, and the console logs, you should be able to audit everything that is currently on the computer and actively going. Welcome to macOS Security Settings, brought to you by IBM. In this video, we'll be learning about the various security settings within macOS. Let's get started. All of the settings we'll be discussing in this video are found within the System Preferences in macOS. System Preferences can be found under the Apple menu or likely on the dock. It's the silver box with the gear in it. As you can see, there are a lot of different preferences to sort through. For the scope of this video, we'll be sticking to the ones that pertain to security and privacy. So that's where we'll start, the security and privacy settings. Within the security and privacy settings window, there are 4 main tabs. When you first open it, it should be on the first, which is General. Here we can see 2 different categories of settings. The first is going to be around the administrator password. This is where you can change that. And then below that, kind of divisible by the line in the middle, is going to be Gatekeeper. It's not labeled, but this is the functionality within macOS that prevents unauthorized third-party apps from being installed. To clarify, a third-party app in this case is any application that's not installed from the Apple App Store. So if you were to just go to an internet browser and download, let's say, Google Chrome for an example, you would get a prompt saying that this is a third-party application. Are you sure you would like to do this? At which point you would have to override Gatekeeper. Now, in some circumstances, Gatekeeper might just tell you that you cannot open a DMG file, which is the disk image, the default installer file in macOS. To get around that, you can actually just right-click the file and hit Open to bypass Gatekeeper that way. The second tab is going to be the File Vault settings. File Vault is macOS's encryption, where it'll encrypt your entire hard drive. This setting specifically is for setting a password for it. This is very important because if you lose this, there is no recovering your data. The firewall settings is going to be an on or off option unless you go under the advanced settings, where you see you can block all incoming connections or whitelist specific ones with a few other options. The Privacy tab holds the most options, and as of macOS Catalina, got a massive overhaul. These settings exist so that when anything tries to access a service or application on your computer, it requires your permission to do so. So things like location services or access to your webcam camera, your microphone, input monitoring, so typing on your keyboard if they want to see key input, if they want to share your screen or share analytics or have access to your files. Every little thing here is going to need your permission. So each application will request it individually. It's not a blanket allow this for all applications. Each new time you launch that application for the first time, it will ask for settings, which many see to be a pain, but overall increases the security profile of the computer. The last thing I want to go over isn't in security and privacy, it's actually under startup disk. This is where you can see any partition that's on the internal drive as well as any connected or networked drives. You can select and restart to boot up into those drives, or you can boot into target disk mode, which turns the current active computer into an external hard drive to show up on another network device. For security settings, we'll see in the next video. Welcome to macOS Recovery, brought to you by IBM. In this video, we'll be learning about the recovery partition and what services it offers. Let's get started. macOS comes with a hidden partition installed that's called macOS Recovery. It essentially replaces the installation disks that come with new computers. So it does offer a version of the operating system you can install plus a few additional utilities. You can access it by restarting your Mac while holding down the R key. It may or may not ask you for an administrator password, and once it boots up, it'll present you with this screen, which is just a small window saying macOS Utilities. The four options that macOS Utilities presents you with are Restore from a Time Machine Backup, if you happen to back up your Mac that way, Reinstall macOS, which reinstalls the operating system, Get Help Online, which is a limited Safari browser window that'll let you have access to Apple support documentation, and last, Disk Utility, which helps us manage the storage on the device. What's nice about the Reinstall macOS option is that it's not an erase and install. It just replaces the OS files, which doesn't touch the user directories. So if there's any issues with the operating system, you can reinstall them with a moderate level of confidence that none of the personal data is going to be compromised. Now, always it's a good idea to have a backup, but worst case scenario, this option does exist. It should also be noted that this will reinstall the operating system that the computer shipped with, not what the most current operating system is. Let's go ahead and break down Disk Utility. Disk Utility offers a lot of functionality in managing the storage on your Mac. The things that you can do really break down into three areas. You can attempt to run first aid to resolve any issues. You can partition or create more volumes on the storage, or you can erase the drive altogether. In order to modify any of the volumes on the storage space, you'll need administrator access. And furthermore, if the disk is encrypted with File Vault, you will need the File Vault key in order to unlock the drive to be able to make modifications. In the event you wish to erase the hard drive, there will be 3 options for you to pick from. After the drive is erased, you get to choose how securely you would like that drive erased. On a standard erase, it's just like essentially dumping the entire contents of the storage into the trash can and hitting empty. Data recovery is still pretty viable at that point in time. However, if you choose the middle option, it is essentially writing over the data 3 times, which meets the U.S. Department of Energy standard for securely erasing magnetic media. The most secure option is writing over the data 7 times, which meets the U.S. Department of Defense 5220-22M standard. If you need even further detail about the drive itself, you can use the info button in the top right hand corner to produce a list of as much information as you could possibly get about the drive. While Disk Utility has a lot of features, more often than not it's used to repartition any type of drive, particularly external hard drives out of the box, which don't usually work with Mac OS due to drivers. You can open it up in Disk Utility, select the drive, reformat it, which will get rid of any proprietary software, backup software that was on the disk, and you can use it as normal. Now, all of these utilities are wonderfully helpful, unless, of course, the hard drive or solid state drive has been reformatted, in which case the hidden partition that macOS Utilities exists on wouldn't be there. So what you can do in that case is what's called an internet recovery. You can access internet recovery by booting holding Option R. You'll see a little globe with a progress bar that indicates it is downloading the macOS utilities. A couple things to note here is that 1, it still will require an internet connection, which it will prompt for, and second, unlike the regular macOS utilities, which installs the operating system that came with the Mac, internet recovery will install the latest version that is compatible with your Mac. And that'll do it for macOS recovery options. We'll see you in the next video.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.
In Module 7, Warren will discuss the concept of virtualization and how it relates to cybersecurity. You'll access several SANS Institute resources. SANS is the most trusted and by far the largest source for information security training and security certification in the world. SANS develops, maintains, and makes available at no cost the largest collection of research documents on every aspect of information security. As if that weren't enough, SANS operates the Internet Storm Center, which is considered the Internet's early warning system. Let's find out some more. In this video, you will learn to describe the benefits of virtualization and how a virtualized environment differs from a traditional environment, describe the role of the hypervisor in a virtualized environment, and describe the role of the virtual machine in a virtualized environment.
Today we're going to talk about some key concepts regarding virtualization. Virtualization allows you to create multiple simulated environments or dedicated resources from a single physical hardware system. On the image on your right side of the screen, you could see 2 infrastructures. The one on the left is a traditional infrastructure where you have your hardware, which is the little purple on the bottom box. And on top of that, you have the operating system, and on top of that, you have your applications. On the right side of the image, you will see a virtual architecture where you have your hardware on the bottom, On top of that, you have your virtualization layer. This could be a software. And on top of that, you have your OS and the application for every single virtual machine. So in this case, every single square that you have OS and app on top will represent a virtual machine. For this virtualization layer, you have the hypervisor, also called the host, which is the host will be the machine that has the hypervisor installed on. The hypervisor is the software or the application that runs on the actual hardware that allows you to virtualize operating systems. And then you have the virtual machines, also called the guest machine, and it's basically anything that you virtualize on top of the hypervisor or the virtualization layer. The hypervisor separates the physical resources from the virtual environment, meaning the virtual machines do not have direct access to the hardware itself. The hypervisor sits on top of the operating system as an end user, meaning you could install an application like VirtualBox, for example, or VMware, or you could also install it directly on hardware. This is also called the enterprise mode, and a perfect example for this is the VMware ESX, for example. On your right side of your screen, you have an image where you have your hardware on the bottom, you have the hypervisor on the middle, and you have your virtual machines on top of that. Finally, you have your virtual machines. It's basically a single data file. It's just like any digital file. It can be moved from one computer to another. You can create a virtual machine in one computer, copy that file, put it in another hypervisor of the same type, and then it should run exactly the same. The hypervisor relays all the requests from the virtual machines onto the hardware itself. So virtual machines do not interact directly with the hardware. They have a layer in between called like we have discussed. It's also called hypervisor. And the physical hardware is assigned directly to the VMs, but it is done through the hypervisor. So you have your RAM, you have your disk. You allocate pieces of that RAM, and you allocate that to different virtual machines. So, for example, if you have a total of 8 gigs of RAM, you could allocate 1 gig to every single virtual machines that you have or you're planning to install. On the right side of your screen, you have the same picture, but now we're talking about the upper layer, which are the virtual machines that sit on top of the hypervisor.
In this video, you will learn to describe moving beyond virtualization to a cloud environment and describe the steps to deployment in a cloud environment.
Welcome. I'm going to talk to you about an overview of key security tools, particularly about virtualization and cloud. So how is it that we jumped from having virtualized environments to this whole cloud systems? We need to talk about first what virtualization is. So virtualization allows you to run software resources with less physical resources. So for example, you can have a server, a physical server, that is running different virtual machines within that server. So that makes you have different environments within or running just a few physical resources. Now, what if we put together several virtualized resources, right? That's one of the questions that people asked a few years ago when this whole cloud thing started. So you jump from a virtualization management, then the whole service delivery automation needed to happen. That aligned to business service catalogs, right? You cannot build a virtualized environment without knowing what you're going to use it for, right? So once you have that business goal you want to achieve, then you can implement this model into your business needs or to fulfill your business needs. Then we had an end-to-end real-time monitoring and optimization and consumption-based mattering and dynamic capacity optimization, right? So this is just a chart that tells us how is it that we jump from this virtualized environments to have this whole cloud environment, right? We jumped from having single resources and single virtualized resources to have a whole level of interacting devices fulfilling a service need. Now let's talk about a cloud deployment and how it looks like, right? And in the previous slide, we talk about how we jump from having just virtualized environments to a whole cloud providing services. Now, in order to understand how a cloud deployment looks like, and you can guide yourself with this chart and the slide, you have 3 steps you need to follow, right? And several interim steps within those steps, right? So you need to first to consolidate the operations you have, and with consolidation we mean what is it that you want to move to the cloud, right? What is it that you want to serve, and what services you need there? Then you need to virtualize that list of items that you did in step 1. You need to virtualize those. Then you need to have resources to do the whole virtualization. On step 2, you need to automate that, right? By automation, we mean like the services and the items you're gonna use to manage those items you consolidate in step 1. Once you have all the structure and how you're gonna manage this, then you're gonna start moving to the cloud. And within the cloud, you're going to integrate and optimize it because you need to measure how it's behaving and how it's performing. You need to make sure that the business needs are integrated to the cloud and that the services you're providing actually are fulfilling what you want for the business. And of course, the optimization, you need to make sure that the resources that you have in place are actually working for what you want, right? You don't want to have, if what you want is just an email, a cloud email solution, then you don't need 100 servers. You don't need to have it co-located in different places, right? And this point is where you need to give it some size. You need to do some sizing exercise so you can optimize your resource and understand if what you have currently and what you've built currently it's enough, or if you at the future will need more resources to keep growing. And this is something you will only know by knowing your business and to know what is it that you want to achieve with cloud computing.
In this video, you will learn to define cloud computing and cloud computing models.
Now we're going to talk about what is cloud computing. We talk about how we end up from just virtualization to have entire cloud environments. But what is it, a cloud computing? Cloud computing is an on-demand availability of system resources, right? So this means that you will have an environment that has virtualized devices that will serve a business purpose, right? And this could be anywhere from storage up to computing power. And the chart you have on your screen, you will see some of the positives and negatives of cloud computing. Now, I have to say that some of the negatives are just perceptions, right? There are facts that could contradict this, but anyways. So let's go on the plus side. So you have choice and agility of business, right? Since you have several virtualized resources, you have flexibility, you can grow in any place around the world, you have integration. That's what it means. You have a scale and cost. So as you may think, having virtualized resources sometimes is cheaper than having boxes for each individual server or service you want to deliver. And obviously this allows us to scale the business as we need. Since we don't need to add hardware to the solution, we can pay our provider to have more resources as we're growing. Then we have encapsulated change management. So this means that the whole management of the system, regardless of how big or how small it is, we can have the single place where we can manage everything. We don't need to be on site in India in one day, and we don't need to be on site in the United States in the other day to be able to manage it. There should be a single point or single place where you can manage all the environment. And of course, as technology moves on, cloud moves on as well. That means that we will have next generation architecture. Every new single technology out there that will be implemented in clouds and will make it more effective and more efficient, providers usually apply those technologies to the service, making it better day to day. Now, let's talk to the negatives, right? So there's a perception out there that since you're sharing resources with other people, security gets compromised, right? And this is not true, but I can see how that perception can fly, right? So, for example, you have let's talk about an email service, right? Let's talk about Gmail, for example. So you have different accounts or hosted within the same physical resources or the same cloud environment, right? So there are countermeasures and there are things and elements that you need to consider for cloud computing that usually those big companies and providers give us. We will cover that a little bit later in this session, but it is in fact a perception that security could be not that proper within a cloud computing environment. Now, the other thing is a lock-in, and this is actually true. By lock-in, we mean that if you have a provider and if you have a whole service based in the cloud and you hired a cloud provider to do this, usually that takes a lot of work, right? So this means that if this provider out of the blue decides to uprise their fees or the fees that you're paying, it might be hard to move away from that provider depending on how much services you have and how much time you have invested. So this could be a drawback for cloud computing. Of course, if this is properly planned, you can do some maintenance and movements to be able to move provider, right? It's not that you cannot do that, but definitely it requires some work. Now, lack of control. So this means that people have the perception that probably since you don't have the devices on site, you're not really controlling them. It's proven that's not the case, right? Even though you hire the service, you still have control. Now, depending on the service that you have, and this is something that we will cover later on, you might not be responsible of doing patching activities, for example, or provide maintenance to the devices because you're not managing them. So you could have lack of control for sure, and also the reliability. And we go back to the same point as you don't have control of the devices. How can I rely something that I don't control? But it is part of the service and of the cloud computing environment. Now let's talk about the different cloud computer types that you can have out there. So the first one being the public cloud. So a public cloud is the most common type of cloud computing you can find out there. Pretty much it's owned and operated by a third party. So you don't need to do pretty much anything other than provide instructions and how do you want to manage it. You share hardware and processing resources with other organizations. This is usually called a tenant. So this means that there's a group of physical resources that is assigned to serve different customers. So you can be sharing those resources with another company. That's what is called a public cloud. Of course, you don't need to purchase anything. Everything is provided by the carrier, which that used to lower the cost. You don't need to provide maintenance. You can scale the environment as much as you like, and it is very reliable, hence being one of the most common options for companies. Now, let's talk about the other type, or the second type, which is a private cloud. And this comes when you're talking about security, right? What if I don't really want to share those resources with another company, right? So this is going to be the option for you. So in private cloud, you don't share resources. You have dedicated resources for your cloud. So this means that you're not going to be part of a tenant anymore, but you're going to have dedicated resources. This allows you for more flexibility to meet specific business needs, right? So if there's a portion of your business that is critical, that you don't really want to have the risk of sharing physical resources with other organizations. You can have, or you can achieve this by having a private cloud. And this allows you also more security because you will have higher level of controls, meaning that, again, you won't share anything with anyone. So you could have a bit more of control of what you have on your private cloud. Now, and as you will think, the third option is going to be a hybrid cloud, where you pretty much going to have the best of both worlds, right? You can control your private infrastructure for sensitive assets. It's kind of cost effective because obviously it's going to be cheaper to grow in the public side than in the private side, because private are going to be resources dedicated to you, hence they're going to be expensive, right? So if you on a hybrid cloud option, you could grow. If you have a portion of your business that is going to grow, you can make it grow in the public side or in the public cloud, and that is going to be cheaper than growing the whole private thing. So it can get cost effective there. Now let's talk about the cloud computing reference model. This is just an abstract chart that describes the functions of a cloud computing environment. It's just a reference to understand how the cloud computing works, right? On your left, you have the consumer, which will be the person hiring the service or implementing the service. The security side is managed by a figure of a cloud auditor, right? It is going to make sure that the security is the proper one, that the privacy is there, and of course, doing control audits to make sure that the information is reliable and it is in good hands. The big box in the middle is the cloud provider, which will provide different services, which might be software as a service, platform as a service, and infrastructure as a service. We will cover this in the next slide. And at the right, you have the cloud broker, which is the people who are in a way reselling the services of the cloud to the cloud consumer. And at the bottom, you can see the cloud carrier, which is the organization who is actually managing the cloud and doing patching of the systems and maintaining everything in order for the service to be effective. Now, let's talk about the models of cloud computing. And this is, you probably have seen this in different places, right? So first we have the software as a service. So the software as a service is a third-party hosting an application and makes it available on the internet, right? You can have Salesforce, Google Apps, Facebook. You have mail services like Hotmail and Gmail. It's pretty much the most common use of a cloud computing service, which is the software as a service. There's a lot of software as a service applications out there, anywhere from web applications that you can find on the internet to do charts or to do graphic on pictures and file editing and a lot of information about software as a service. So what I wanted to take away with this is that software as a service is based on the cloud and is the fact that you can use an application, an actual application that you could get benefit from online, right? You don't need it in your computer. You don't need to install anything. You can just, it is host out there and you can use it. Then we have the platform as a service. And as you may infer here, you're actually getting your own platform. You're not getting any more an application, but it's a whole platform that allows you to develop or run or manage applications without the complexity of maintaining your own infrastructure. Right? You don't need to have your infrastructure there, so you will purchase from a vendor the environment where you will run your tasks, right? This could be from middleware, from a database environment, a Java sandbox where you can develop applications, where you can have developers working in there. You don't really need to have the whole platform to do that, but you will purchase that from a vendor that will give you that service. That's the whole spirit of the platform as a service. Then last but not least, you will have infrastructure as a service, which delivers a whole computer infrastructure anywhere from storage, servers, network devices, etc. Right? You can have a whole data center as a service, and this will be your infrastructure. If you don't want to purchase network devices, if you don't want to have routers or switches, if you don't have space for them, you could actually get those in an infrastructure as a service model, where you can purchase the right to use or the networking device, and you could use it remotely, and it will serve all of your needs, but you don't have the actual device in there.
In this video, you will learn to describe the benefits of cloud computing, describe the components of cloud security, and define the importance of a cloud governance process.
Now we're going to talk about the cloud benefits, a little bit about cloud security, and the importance of have a proper governance around your cloud computing environment. So what are the benefits of cloud computing based on everything that we have covered so far? So first of all, you have flexibility, right? You have the capability to grow an environment according to your business needs. You're not attached to a single place. You can have access to the resources from wherever you are in the world, and you don't have limitations about it. So cloud computing, as you may guess, comes very handy and very flexible. The second one is efficiency, right? The fact that you can you can join a meeting using WebEx, whatever you are, and at whatever time in the world that you are, right? And the fact that you can add more resources to make speeds more efficient. That's what we call efficiency in cloud computing. And of course, and the most important thing is the strategic value. The fact that the same flexibility that we talked about a few seconds ago allow us to guide the strategic items about cloud computing with our strategic goals or organizational goals, right? So the fact that you can guide those in the same direction makes a lot for the strategic value of a business. Now let's talk about cloud security. When you have a cloud, remember that in the first slides, we mentioned that one of the perceptions about cloud computing is that you don't really have security. Well, that's not true at 100%, right? You do have cloud security, and these are just some of the items that you have to consider when you want to establish or you want to have proper controls in terms of security around cloud. So first of all, you need to have a disaster recovery and business continuity planning in place, right? So you want to think about what happens if my vendor is under an attack, or what happens if my vendor has a power outage that can provide more services. You need to think about it as a disaster, right? So do I need to have another provider? Do I need to have a backup just in case? Do I need to have copies of my backups and run books about how I did the whole implementation of the cloud in case I need to go and look for another vendor? All of that needs to be well established and planned in the disaster recovery and business continuity. Then governance, and we're going to talk a little bit more about governance in the last slide, which is the next one. But you definitely need to have some governance around cloud computing, right? Who's going to be in charge? What parties need to be involved? What is going to be the communication plan? What are going to be the flows? What I'm going to expect out of the cloud environment? All of that needs to be properly established. Of course, compliance, and with compliance we mean for how long, for example, I need to have the logs from a cloud computing. Is that cloud computing compliant against any regulations that I might have in my organization, right? Is it compliant with the policies I have in the country that I'm based at, right? Let's talk about, for example, GDPR, right, in Europe. Is my cloud computing environment compliant with GDPR? Is it going to violate any information from my vendors, of my customers across the world? That's something that we need to really consider about cloud computing. Of course, availability, and this ties into the disaster recovery plan as well. What happens if my vendor is out of service? Do I have another vendor? the information that is within the cloud. What happens if it's not available anymore? Do I have a website? Do I have a server on site that can host the website that I have hosted in the cloud? All of that is information that I want to have in mind when putting my security framework around the cloud security. Of course, data security. Is the information encrypted? How is it gonna travel from my company to my cloud vendor? What safeguards my cloud vendor has in place, right? That's something really important. We want to make sure we have periodic audits in our cloud or within our cloud provider to make sure that our data is safe out there. Particularly if we have that, or if we have an infrastructure based on a public cloud. And something really, really important is the identity and access management. We want to make sure and we want to have a record of who is accessing what, where, how, and why, right? That's really important. We need to make sure that access management is a must. The fact that we have a third party managing the cloud environment doesn't mean that we still need to track and need to have access to those logs and visibility to those logs. So all of these items we just talked about in conjunction made for a good cloud security strategy. Now let's talk about cloud governance, and this is going to finish the cloud security portion of the slides. In order to have an effective cloud strategy, you need to have a very good cloud governance. And the only way you can have a good governance around cloud is that this governance is aligned with the service and with the organization, which is the little circles you see on your right side. And as you see there, the three of them, the governance, the service, and the organization, need to overlap in different places, right? You cannot have governance if it's not aligned to your service or the service you're providing in the cloud. And of course, the service you're providing in the cloud needs to be aligned with the organization goals, right? And the organization goals, of course, need to have or need to be involved with the governance. So as you see, it's a little triangle. You cannot really sacrifice any of the points on the triangle. All the three need to be there and need to be aligned, as I said, with the service, with the organization, with the governance in order to have an effective cloud security strategy.
Thank you for attending this course. If you're interested in acquiring additional skills in cybersecurity, we hope to see you again.
Thanks you for watching my video. Please like and subscribe my channel. Thank you for spending your valuable time with us. Your views and support mean the world to us. We couldn't do it without you. Thank you for being a loyal viewer.